Hello, and welcome to my channel, Code Dog. Today's video starts a new series called Python Code Review, where I will be going over Python code I've written for you, the viewer, to absolutely roast the shit out of me. Okay, maybe don't roast the shit out of me, but I would like to receive feedback to help me grow as a programmer. If you're new to Python and don't feel like you can offer feedback, stick around anyway. I'm not a total noob, and you might pick up a trick or two from this code. In today's code review, I'll be going over some code I wrote, as one does, to solve a particular problem, which is this: how to apply a command line tool to data stored in table format. I won't go into why you might need to do this, as that's not the point of this video, but here are some examples of it being used so that you can better understand why I did things the way that I did. So the name of the command is tbldo, because it is we're doing things from the command line to some sort of table. And that can be either a CSV or SQL database, at least with the current version of this code. If I do a help on it, you can see what it expects. So the first argument is going to be either CSV or SQL. That tells us which mode we're going to be running in, which will influence the inputs that it expects. Then also have some options like the help. The help gets automatically generated from argparser, which we will see when we get into the code. You can also specify the number of threads, so you can kick this off in a threaded fashion. And then you can also add a verbose command, which basically is just going to tell you what command you're running. So let's try an example. So tbldo CSV mode, and then I'll go ahead and add the verbose onto this. So that's something I might want to fix in a later version is the options need to come before the specification of whether it's CSV or SQL do. But anyway, that's what is happening. So let's take a look at the normal output, right, without the verbose prints. Where are we? So that's what it would do normally. And then with the verbose option, it's just saying, it's basically just printing out the command after the arguments have been substituted into them. So basically the arguments you want to substitute are wrapped in these brackets and then chosen according to their column name, right? So I can reorder these. I'll get rid of the verbose now that you see what's going on. So I can do arg1, arg3, and arg2, and we see it's xzy instead of xyz. tbldo can also work with SQL databases. So I have an example database written in SQLite with effectively the same columns, and running in SQL mode looks like this. Running in SQL mode does look like CSV mode. One of the differences being that instead of specifying a path, you specify what is called a database connection string, which is part of the SQL Alchemy library that I leverage in my code. And then you specify a SQL query, right? Because a SQL database has multiple tables and you want one table. So a query effectively will return a table that you can act on. And if we want to see what this looks like, the SQL looks like this. So it's selecting from this test table, it's selecting all of them, setting them to be a temporary table for some reason. I can't remember why I did that in my test code. Probably to test out the multi-command capability or multi-statement capability. And then you're just selecting arg1, arg2, arg3 from that temp table, effectively giving the same results as the CSV with the same columns. Okay, so that's the overview. Let's dive into the code. The entirety of this tool is written in a single module called __main___.py. Within it, I have a few functions, including the main function, which effectively serves as an entry point for the program. Immediately, I make use of the argparse module. If you haven't heard of argparse and you write command line applications in Python, I can tell you with 100% certainty you're doing it wrong. Argparse allows you to define command line arguments for your Python application better than any other language I have come across, and it's not even close. Anyway, I first define my main parser with a description of what the purpose of the command is. I then create two sub parsers. This is because I want the tool to run in two different modes, CSV and SQL, both of which will take in slightly different arguments. The subparsers allow me to distinguish on the command line which mode I will be running in. If CSV is the first argument, then I'm running in CSV mode. If SQL is the first argument, then I'm running in SQL mode. CSV mode will expect the command that will be applied to the data first, followed by the CSV file which contains the data. You can also specify which delimiter your CSV file uses. This is optional and the default is a comma. I also make use of the parser setDefaults function. This allows me to attach the function I want to be called in the given mode. SQL mode will also expect as its first argument the command to run, but as its second argument it expects something called a database connection string. This is similar to a file path, but includes a prefix specifying what kind of database is being used. The final input is the query to be applied to the database. This is necessary since the data is expected to be a single table, and a database contains multiple tables. A query on a database defines a single table that the command can be applied to. I also make use of the setDefaults here for the SQL specific function. I finally add some optional parameters that can be used in both CSV and SQL mode, which is the number of threads to use and whether or not to have verbose prints enabled. Calling parser.parseArgs takes in the command line arguments and parses them into something called a namespace, which I then pass into whichever function got selected for the mode we are in via the setDefaults function, either CSV_do or SQL_do. Let's take a look at those. In the case of running in CSV mode, I immediately leverage pandas to get the CSV into an in-memory format that is nice to work with, the pandas data frame, making sure to specify the delimiter provided by the user, or the default of a comma. I then make use of a thread pool executor in order to leverage any multi-threading specified by the user. The executor exposes a method called map, which behaves like the Python built-in map function, but will run in a multi-threaded fashion. For those aware of the global interpreter lock, or GIL, note that we will not be impeded by it. I will explain why when we get further down. The runDfRow function is what gets mapped to all the rows in the data frame. It substitutes the values in the row according to their column name into the command specified by the user. It then calls run command, which simply leverages the subprocess module's run function to run the command in the shell. Because the actual processing is being done in the shell and not in Python, the GIL does not apply, and multi-threading actually has the effect of speeding up the entire set of processes. Of course, how much of an effect multi-threading has will depend on how heavy the processes are. If it takes more time to spin up a new thread than it does to run the command, you likely won't see much of a speed boost. For the most part, SQL mode runs similar to CSV mode, the key differences being the steps to get the rows substituted into the command. In the SQL_do function, for example, I need to make use of the SQL Alchemy library to connect to the database and execute the input query. I then extract the column names from the description attribute of the query result and make use of them in runSQL_row, which is also running inside of a thread pool executor. RunSQL_row is nearly identical to runDfRow, the main difference being the additional argument for the column names, as well as how the substitution dictionary is generated. After that, it calls the same run command function to run the command. And that is my approach to solving what is perhaps a niche problem, but a problem I have run into nonetheless. If you like the content of this video, I'd greatly appreciate a like on the video. And if you're interested in seeing more, go ahead and subscribe. And for those of you just chomping at the bit to tell me all the things I've done wrong, go ahead and let me have it in the comments. I'm here to learn and help others learn as well. This is CodeDog, signing off.